All right, we're going to do part two here, where where we're going to solve these right triangles where the radius or the hypotenuse does not equal 1. For 2 and 4, I clump these two together because they don't give us an ordered pair. They actually give us a value of a certain trig function. Okay, now it gives us that cosine of theta is 5 over 13, and the terminal side's in the first quadrant. So the most important thing you have to do is draw the picture. So again, I'm going to put the picture up top. So I'm going to draw this in the first quadrant. I don't know what the ordered pair is. I'm still going to have it going out. I put it down here. Now, but this is theta. And if we remember our definition, cosine is, what is it? It's adjacent over hypotenuse. So if this is theta right here, the adjacent side is right here, that's 5. The hypotenuse is 13. So what's missing is this side right there. Now that should be another Pythagorean triple. I think in the first video, part 1, 3, 4, 5 was one. This one, the question mark, is 12. It's going to be 5, 12, 13. Well, let's just do the quick work for it. If you didn't remember that it was 12, you could use Pythagorean's formula, and you could just say 5 squared plus, I'm going to say this is the opposite side. Say the opposite side squared equals the hypotenuse squared, which is 13. So you get 25 plus the opposite side equals 13 squared is 169. Then after you subtract 25 from both sides, you have the opposite side squared equals 169 minus 25 is 144. And then you take the square root of 144, and you get 12 to be the opposite side. So let's put this in here. This is 12. Then from there, it's just all SOHCAHTOA. Just use your definitions. All right, so let's do this. Cosine of theta. Now, the good thing about this, it's in the first quadrant, so all the trig values are going to be positive. So cosine of theta is 5/13. So it's reciprocal of secant. We just flip it. So it's 13 over 5. Sine of theta, that's opposite over hypotenuse, so it's 12 over 13. Reciprocal of the sine is cosecant, so we just flip that and get 13 over 12. Then we do tangent of theta. This is the TOA, this is opposite, which is 12 over adjacent. I forgot to put this here, this is adjacent. So it's 12 over 5. And then cotangent, we just flip that, and it's 5/12. So these are all the trig values, they're all positive, because theta is in the first quadrant. Again, I'm not finding out what theta is, I just want to know what the trig functions are equal to, the ratio for all these angles. Okay, let's do one more, let's do 4. Again, main thing is drawing the picture. It's saying this is in quadrant 3. So if I draw this, okay, I have to go to the left from the origin. I draw it down here to quadrant 3, and then I go up to make the right angle. Again, this is theta, and it gives me cosecant is -2. Now, if it gives me cosecant is -2, whenever I see cosecant, I want to change it. I want to put it back into terms of sine. Much easier. Just like if you were given secant, put it in terms of cosine. So if cosecant of theta is -2, then sine of that same angle, you just flip it, it's -1/2. So then what this is going to be, sine is opposite over hypotenuse. So I'll say opposite over hypotenuse. So I'm going to make the hypotenuse 2. I'll make that 2. I want to make the opposite side. Now this is going to be the opposite. I want to make this 1. Instead of putting -1, I'll put 1. This is what I have to figure out, the adjacent side. So I use Pythagorean's formula. It's going to be 1 squared plus the adjacent side squared equals hypotenuse squared, which is 2 squared. And here you can see pretty quickly, you're going to get what? 4. 4 minus 1. The adjacent side squared is going to equal 3. Take the square root. The adjacent side equals square root of 3. So let's erase this. I want to put in square root of 3. And here's the one thing to remember. Quadrant 3, even though I didn't put negatives in here, I still have to remember that every trig function quadrant 3 is going to be negative except for, what is it, tangent and cotangent. These are the only ones that are going to be positive. So let's just remember that. Okay, and then if I set it up, let's see here, 1's the opposite side, 2's the hypotenuse, root 3 is the adjacent side. Okay, and let's start what we're given. Cosecant of theta is -2, so we figured out sine of theta is -1/2. Let's do cosine of theta. That's the ka. That's adjacent over hypotenuse, so it's root 3 over 2. And I have to make it negative, so it's negative root 3 over 2. I flip it for secant, and it's going to be what? Negative, and you've seen these values before. These are actually in the unit circle. So when you rationalize it, it's -2 root 3 over 3. And then if I do tangent of theta, now this is the only one, this and cotangent, the only one's going to be positive. This is opposite over adjacent, so it's 1 over root 3. So 1 over root 3. If you rationalize it, it's root 3 over 3. So we just circle these as we go. And then cotangent, we just flip it. So this was originally 1 over root 3. I move that to the top. It just becomes the square root of 3, or the square root of 3 over 1. Okay, so these actually corresponded to a special angle in the unit circle. But that kind of shows you, even though the radius wasn't 1, if everything is proportional, you can still get it to go back to either 30, 45, or 60.